Hello, pre-calculus students. Welcome to Unit 3. Hopefully you've done your warm-up and you've checked those answers online. If you have questions about the warm-up, make sure you see your teacher, but right now I'm mainly going to focus on the lesson. So, Lesson 1, you have some reminders. Here are some trigonometric ratios with the reciprocal function, so sine equals 1 over cosecant, or cosecant equals 1 over sine, and then of course cosine is related to secant, so 1 over secant is cosine, or secant is 1 over cosine, and then tangent equals 1 over cotan, or cotan equals 1 over tan. None of that information will be given to you on the test, so you need to remember those associations with one another. Tan equals sine u over cosine u, that will be given to you on a test, but of course then if you reciprocate that, you're just going to turn that fraction upside down. The other formula that will be given to you on a test or on quizzes and tests on your assessments will be this one, this Pythagorean identity, but we will not give you the other two. Those you can create on your own. Remember, you did that in your warm-up. They're by dividing each of these terms by sine squared u, which would result in this one over here, 1 plus cotan squared equals cosecant squared, or instead you could divide each one by cosine squared u, which we would get tan squared plus 1 equals secant squared, which would result in this equation here. So the only thing that will be given to you on the quizzes and tests are these two formulas right here. Even and odd identities, we will talk more about this, about algebraically how to do it, but if you put in the opposite of x, you're going to get the opposite of y. So if we put in the opposite of x, we get the opposite of y. That's what an odd function is. So a sine function is an odd function. A cosine function is even. When you put in the opposite of x, you get the y just as is. So this one is even. Even functions graphically are reflections over the y-axis, right? So they're reflections over the y-axis. Over the y-axis. And odd functions have rotational symmetry. So specifically, their rotational symmetry is 180 degrees about the origin. So they rotate 180 degrees about the origin. If you see the same picture as the original, then we know it's odd. So again, we'll talk more about these. The reciprocal functions, if this is odd, or you can check it and graph it. But your tangent function is also odd because you're getting the opposite here. So this is odd, even, and odd again. But we'll talk more about that as we go through the unit. Okay, example number 1. This should be a review of last year. We're trying to find the 5 trigonometric functions based on these two pieces of information that have been given. We know that secant of some angle u is equal to -3/2, and we know that tangent of that angle u is greater than 0. So those two pieces of information are going to help us identify which quadrant we are in. Because secant is negative, secant is the reciprocal of cosine, cosine is positive in these two quadrants, so we've eliminated quadrant 1 and 4. And then because tangent is positive, tangent's greater than 0, we now know we're talking about quadrant 3. So then we use this fraction right here, so I'm going to draw my right triangle so that it looks like it's in quadrant 3. Oops, that was wrong. Oops, sorry, I meant to get my eraser. I drew the triangle wrong because if I'm drawing for quadrant 3, it should come down because your reference angle is right here at the origin. This will be my origin. This is my reference angle right there. So secant is associated with cosine. It's 1 over cosine. Cosine of some angle is equal to x over r. Therefore, secant of this angle is equal to r over x. So my radius is equal to 3. And my x-coordinate, is equal to -2. How do I know that's the negative? Well, because if we're in quadrant 3, we would have to go left some amount, some distance. And so going left is a negative number, so therefore I know it's going to be -2 going to the left. Then I have to find my y value. So this is a right triangle right here. I go left 2 units, down y units, and the radius of the circle is always positive, and it's positive 3 in this case. So Pythagorean theorem says negative 2 squared plus y squared equals 3 squared. 4 plus y squared equals 9. Y squared equals 5. Therefore, y equals plus or minus root 5. Well, again, is y really positive or negative? No, it's in the third quadrant, so we're going left and then down. So really, y is equal to negative root 5. It's a negative sign right there. So now that we know we have y is negative 5, x is equal to negative 2, and r is equal to 3, we can find our other 5 trigonometric functions. So sine of u is equal to y over r. Cosine of u is equal to the reciprocal of negative 3 halves. Tan of u is equal to y over x, but they're both negative, therefore it turns into positive. Now all I'm doing is reciprocating. So these are your 5 or your 6 answers. This was given though, and so all 4 should be negative except for tan and cotan. Remember, you do not need to simplify a radical in the denominator. You do not need to rationalize that. You can keep them with the radical. That's fine. We'll accept that. Okay, moving on. Simplify the following expressions and write as a single term when possible. So this word simplify, what does that mean? That means we're trying to break this expression down into the simplest terms possible. So this is sometimes a little tricky, but we try to say, okay, we want to try to get it down to a single term, which means we shouldn't have pluses and minuses in our final answer if it's a single term. So we have to look at strategies of what we can do to simplify this. So we might factor, we might substitute in sine and cosine for any other functions that aren't sine and cosine, and then use a factoring strategy or something else. So here we have a sine times cosine squared minus sine of x. So I can factor out my sine of x. When I factor out my sine of x, I'm left with cosine squared x minus 1. Well, we have this Pythagorean identity, remember, cosine squared plus sine squared equals 1. If I did cosine squared minus 1, that I move the 1 here to the left side by subtracting. That means I have to move sine squared to the other side by subtracting, so I would get a negative sine squared. So I can replace cosine squared minus 1 with negative sine squared x. So I have now sine of x, doesn't do anything, we can't change that, but I've taken cosine squared x minus 1 and I've replaced it or substituted in negative sine squared x. So now what can I do? They're both in single terms. I can just multiply them together. Sine to the 1 times sine squared. We just get negative sine to the 3rd power x. So positive times negative is negative. Sine 1 times sine squared is sine cubed. And that's it. Next one. We have cosecant minus cosine x cotan x. Well, I don't see anything I can factor out right away. So instead, I'm going to look at things like cosecant and cotan, and I'm going to replace them with sines and cosines. So cosecant is the same as 1 over sine of x. And then I put minus cosine x times, and cotan is the same as cosine over x, or cosine x over sine of x. Now, basically, because these two fractions are multiplied, or these two things are multiplied together, I can just make this one big fraction. It's cosine squared over sine of x, because 1 times sine is sine, cosine times cosine is cosine squared. So I can combine this into one giant fraction because they have a common denominator right here. So it's 1 minus cosine squared, and then all over sine of x. Well, what is 1 minus cosine squared? If I move the cosine squared over here by subtracting, That just equals positive sine squared x. So I can replace my numerator with sine squared x, divide it by sine of x. Well, what can I do? I can cancel this sine of x with one of these. So my final simplified answer is sine of x. Okay, next. If we have fractions and we have two different denominators, there's nothing else I can do here. So my strategy is to get a common denominator. So this first fraction, I'm going to multiply the numerator and denominator by 1 minus sine of x. My second fraction, I'm going to multiply the numerator and denominator by 1 plus sine of x. And then I'm going to see what happens. So 1 times 1 minus sine of x. So in my numerator, I have 1 minus sine of x. Plus, here, positive 1 times 1 plus sine of x. I just get 1 plus sine of x. And in my denominator, I'm going to multiply 1 minus sine of x times 1 plus sine of x, which is 1 minus sine squared x, because those are the difference of squares. So the inside and outside terms cancel. So I just have 1 minus sine squared. Well, what is 1 minus sine squared? Again, going back to this identity up here, if I subtract my sine squared, 1 minus sine squared x would equal cosine squared x. So now I can replace this denominator 1 minus sine squared x, with cosine squared. So I get cosine squared x here, my negative sign and my positive sign cancel. So I get 2 over cosine squared x. Well, that's the same as 2 times 1 over cosine squared x. And what is 1 over cosine squared x? Well, that's just the same as secant squared x. So my final answer, simplified answer, is 2 times secant squared x. For letter D, don't freak out about the logarithm. You just have to remember the rules. If you have log of m plus log of n, because they have the same base, maybe we put a base b, that just becomes log base b, and then we multiply m times n. So that's what we're going to do here. We're going to multiply secant, which is 1 over cosine, times sine. So I've replaced secant with 1 over cosine. Well, that becomes sine over cosine, which is just simply tan of x. So log of the absolute value of tan of x. And why does it have to be the absolute value? Because the base, no matter what, when you raise it to a power, this base has to be positive. It's going to result in a positive number. Okay, this one, rewrite cosine theta divided by 1 minus sine theta so that it's not fractional form. I believe you guys have a cosine squared theta. So what do? We're just going to multiply. Oh no, we don't need to do that, sorry. If you have a cosine squared theta, you're going to replace the numerator, right, with 1 minus sine squared theta. And then you can factor that numerator, right? It's a difference of squares, so that factors to be 1 minus sine theta times 1 plus sine theta all over 1 minus sine theta. So you can cancel the 1 minus sine thetas, and you got rid of the fraction by just making it 1 plus sine theta. If you just have the regular cosine, which I don't think you do, but if you do, check the answer key for a different answer. All right, that's it. So I thought I had another example, but I don't. So again, if you had a different problem here for this last one, check the answer key that's online. Otherwise, hopefully this helped. This was the simplification process here. We simplified all of these original expressions by getting rid of pluses and minuses and making them one single term, with the exception of the last one. So I hope this helped. If not, then pop in and see your teacher. Bye.